If we take a look at MT12, LT4, we're going to look at permutations and combinations. Permutations and combinations are just a fancy way of saying how we're going to count. It's a way we're going to count. First thing I want you to do is let's do the first 6 problems. Make sure we go over those in class. Now, a permutation is just an arrangement where order is important. We give an example of if you have a playlist of songs. If you play Taylor Swift first and you play Keisha second, that's different than Keisha than Taylor Swift when you listen to it, isn't it? So what happens is we're going to look at all the different ways. We're going to use the fundamental counting principle to find the different ways that we have 7. So we have 7 songs. In my first spot, I've got 7 songs I could play. So if I play that song and I don't repeat it, there are 6 songs available for the second slot. And then I would keep on going. There's 5 for the third slot, then 4, then 3, and then 2, and then you only have 1 song left for the last slot. So to find that total, we're going to multiply them together. That is called factorial, where you multiply all the positive integers down to 1 from that number. It has a kind of a weird symbol. It's an explanation point. So we have an explanation point. That means factorial. So if I wanted to find the total number of ways I could have a 7-song playlist on my calculator, I would just do, whoops, made that too big. What happened there? Okay, I'll go 7. And then, depending on the calculator, I hit the function here. There's my factorial. Know that you have 5,040 different ways to play your playlist of 7 songs. Now, what happens if I only want to play 4 songs on my playlist? Well, in my first slot, I still have 7 songs available, then 6, then 5, then 4. But I'll stop when I have 4 songs. Now I'm down to 840 different ways to play 4 songs. That's called a permutation. So rather than going all the way up to the end, we'll call that a permutation. It's got this formula. It says n factorial over n minus r factorial. R would be the number of songs I have. So I have 7 songs, and I'm only going to choose 4 of them. So then what I do is I go 7 factorial over 7 minus 4 factorial. Notice my 3, 2, and 1s, they reduce out. So it's 7 times 6 times 5 times 4, and we get 840. So if you don't want to list all those, that's a good way to do it by using the permutation. Now let's take a look at a problem here. We have Elena and Ruby. They're going to go to open night, and they're going to be along with 32 people, and those slots are going to be filled randomly. So I want to know the probability that Elena will perform first and Ruby will perform second. So if we think here, my sample space, that's going to be 32 for the first slot, 31 for the second slot, 30 for the third slot, and so on. I can write that as 32 factorial. Now, that's going to be a huge number, isn't it? Because if I think 32 times 31 times 30, it's going to be a big number. I'm going to leave that as 32 factorial for now, although I could probably go my calculator and find it. Now, favorable outcomes. In my first slot, I want Elena to go first. So there's one choice, only Elena. My second slot, then there's only one choice, Ruby. Now my third slot, doesn't matter who goes. So I've got 30 other people who could go in that third slot. And then my fourth slot would be 29. So in other words, I'm going to have 1 times 1 times 30 factorial. So the probability that we have Elena, then Ruby, is going to be 1 times 30 factorial, or 30 factorial, over 32 factorial. Now, I could write that out. I could write 32 factorial as 32 times 31 times 30 factorial. And then notice my 30 factorials reduce out. So I'll get 1 out of 32 times 31. And 32 times 31 is going to be kind of a big number, so I'm going to write that as a decimal. So I'm going to take 1 divided by 32 times 31. In 0.001, not a very high probability, isn't it? We're at less than 1%. So the probability that I would get that would be 0.001. Now, if you're asking yourself, do I have to do that? Not really. This is just a way to show you how we get the where they come from. But if I think about this, for Elena to go first, she's 1 out of 32 contestants, isn't she? Ruby to go second will be 1 out of 31 contestants. That's where it comes from. Now let's take a look at one where we do want to use a permutation. So in example 2, we've got a project in Sienna is going to select 12 family photographs that randomly going to be played in a slideshow. The slideshow is not going to repeat until all 12 photos have been shown. It says 3 of them are the entire family, 2 of them are of her brothers, 3 of them are just her, and 4 of the photos of her sisters. I want to know what's the probability that the first 4 pictures in the slideshow will be Sienna's sisters. Well, we're going to start here with our total, our sample space. That means my first photo, we could have 12 pictures. Our second photo, we could have 11 pictures. My third photo, I could have 10 pictures. And my fourth photo, I could have 9 pictures. What this is a permutation of 12 things 4 at a time. So if I do a permutation of 12 things 4 at a time, I can show that on my calculator here. So I will do a permutation of 12 things 4 at a time. Lost my comma here. There it is. So there are 11,880 different ways we could have these photographs displayed. Now my favorable outcome says I could have 4 of the sisters. There's 4 photos of the sister. My second slot, three photos of the sisters, then 2, then 1. So that's going to be 12, 24. There's 24 different ways we could display pictures of just the sisters. So my probability that I'm going to get the 4 sisters is going to be 24 out of 11,880. So if I do 24 divided by 11,880. Then we'll get about a 2% or less than a 2% chance, right? So 0.002 probability that the first 4 pictures will be of the sisters. Now, if you have to happen a problem where they repeat, what we're going to do then is we're going to what was I going to say? We're going to divide by the number of ways it can repeat, because repeat means there's more than one way to do that. So that's all we do for that one. So if we take a look here, let's take a look at a problem that repeats. On a game show host, the contestant has arranged 5 number titles to build their guests at the price of a prize. Sydney is given 5 tiles with the numbers 2, 2, 5, 5, 8. If she arranges them randomly, what's the probability that she arranges them in the correct price? So, first off, what I'm going to do then is I'm going to look at my sample space. And she's picking 5 tiles. So that's 5 times 4 times 3 times 2 times 1. That's all the different ways she could arrange those tiles. But notice 2 is repeated, isn't it? So I'm going to divide that by 2. Now my problem says 2 factorial, so I'll do like we do it with the problem, because we might have more later on. And then the 5 repeats, that's 2 factorial. The 8 doesn't repeat. So in other words, we're going to get 5 factorial is 120. 5 times 4 times 3 times 2 over 2 times 2. So 4 of them can repeat. So in other words, we have 30 different ways we can arrange those tiles, because some of them repeat. And then there's only one way out of those 30 that gives me 25,852, isn't it? So the probability that Santa just pulls them out of the bag and she wins is going to be 1 out of 30. Not very high, is it? And then 1 out of 30, let's write that as a decimal, because I like to put probability as a decimal. And we get 0.03. So she's got a 3% chance, maybe a 3.3% chance of winning, just by picking them randomly. Oops. Now, a combination is where the order matters. Or I said that back. The order doesn't matter. So if I pick 3 people to win a prize, the order we pick them doesn't matter. They still win a prize, don't they? So that, because the order doesn't matter, we're going to divide out by the fact that I could have the same order. So if I have n things r at a time, it's n factorial over n minus r factorial times r factorial. That's how we do it by hand. We don't do that very often by hand. We'll just use a calculator with NCR.